Good morning, friends. My name is Chirag Bansal, and today we will learn about counting sort. Counting sort is an efficient way of sorting numbers if we know the range of the numbers and the range of the numbers is small. Here, in counting sort, the time complexity is order n plus k and the space complexity is order n plus k as well. As you can see, if k is small, then it is more effective than quick sort and merge sort, who have a best case sorting efficiency of order n log n. As n k is small, then we can also say that order n plus k is almost equivalent to order n, which is obviously better than quick sort and merge sort. So let's look at how we do it. So we have three arrays. One is the original array, which has been given to us of size n, where n is the number of elements. We have the second array called the count array of size equals to k, where k is the range of the numbers. And then we have the third array, which is the output array of size n, where n is the number of elements. So what do? We iterate over the original array, and then whenever we encounter I, we increment count I, which means count I will represent how many times I has come in the original array. Then what do? We sum count I with its previous value. So every value of count I will contain the sum of each cell before that. Then what do? We iterate over this count I and assume count I is the location of I. If the location of I is empty, we put I there and then we decrease count I and then we do it again till we have till we locate a location which is filled. Let's look at an example to understand better. Here we have an example. We have been given that the array will be of range 0 to 9. So we create a count array of size 10, which has values from 0 to 9. And then we have an original array which is given to us. So what do? We iterate over the original array, and whenever we find I, we increment count I by 1. So we iterate over the original array, we get 1, so we increment count 1 by 1. Then we go to at this location, we increment count 7 by 1. Similarly, we do that. So we get this final count array, where each count I represents how many times I has come in the original array. As 1 has come 2 times, its value is 2. As 3 has come 2 times, its value is 2 as well. Then we iterate over the count array and then sum each value. So we get 0 as 0, 1 as 2. The third index will have value 2, and then we sum it in a similar manner, and then we get this final count array. So what do we do after that? We iterate over the count array, we go to the first location. Hey, where should we put 0? As there is no location, we don't do anything. Then we go to 1. As its value is 2, we put 1 at the second location, and the second location in the array will with the first index. So we put 1 here. Then we decrease it by 1, we get 1. Then we go to the first location and we put 1 there, which is, as it is empty, then we minus increment by 0. Decrease it by 1, so it becomes 0. Then we go to the second element. This 2 has been should be stored in location 2, but 2 is filled, so we move on, which means basically there is no 2 in the original array. Then we go to 3. 3 should be at location 4, so we put 3 at location 4. Then we decrease it by 1. 3 should be at location 3, so we put it at location 3. Now then we decrease it by 1. It should be at location 2, but 2 is filled, so we move on. So we go to 4. 4 should be at location 5, so we put 4 there, and then we follow the same process, and finally we get the array as 1 3 3 4 7 8. This will be the final output array which we need. As you can see, what it basically does is it counts how many times each number has come and then puts it at that particular location. Let's look at how the time complexity is calculated. As we iterate over the original array once in order on time, then we iterate over the count array once in order ok time, then we iterate over the count array again in order ok time. So the total time complexity is order n plus k. And then how do we calculate the space complexity? As we have created 2 more arrays, one of size n and one of size k, the space complexity is order n plus k.